Flight 19 mystery is that the flight instructor, he said that his compasses were out. Well, if you're in a thunderstorm, there were thunderstorms in the area, a thunderstorm will make a magnetic compass spin, and you just kind of lose control. I don't know where we are.
For nearly 8 decades, the disappearance of Flight 19 has remained one of aviation's most enduring mysteries.
So there's an argument that says at least some of Flight 19 may have disobeyed Commander Taylor's orders. I mean, there's a breaking point in the chain of command.
5 Navy bombers vanished without a trace on December 5th, 1945, followed by the rescue aircraft sent to find them. This incident became the cornerstone of Bermuda Triangle lore, spawning countless theories from compass malfunctions to alien abductions. But recent scientific breakthroughs have finally shed light on what actually happened to these aircraft and their 27 crew members. Using advanced technology and meticulous analysis, researchers have pieced together the puzzle that has baffled experts for generations.
The wing, propeller and double radial engine. The gunner's turret with a pane of bulletproof glass.
This is the story of how science finally unraveled the fate of Flight 19. On December 5, 1945, the skies over Fort Lauderdale, Florida appeared relatively calm as 5 TBM Avenger torpedo bombers prepared for takeoff. The weather report indicated moderate conditions, temperatures around 67 degrees Fahrenheit with scattered showers. Nothing that would typically concern experienced pilots. At 2:10 p.m. Eastern Standard Time, Flight 19 departed from Naval Air Station Fort Lauderdale for what should have been a routine 3-hour training exercise. The mission, designated Navigation Problem Number 1, was straightforward: fly east to conduct bombing practice at Hens and Chicken Shoals in the Bahamas, then turn north over Grand Bahama Island before heading southwest back to base. Leading the squadron was Lieutenant Charles Taylor, a seasoned aviator with approximately 2,500 flying hours, including combat experience during World War II. The 14 men aboard the 5 aircraft were a mix of students and instructors. Most of the trainees had accumulated substantial flight time, but this particular exercise would test their navigational skills over open water. Each plane carried enough fuel for about 4 hours of flight, providing a reasonable safety margin for the planned 3-hour mission. The first leg of the journey proceeded without incident. Radio communications confirmed the squadron had reached their practice area and completed their bombing runs. It was during the second leg that things began to unravel. At approximately 3:50 p.m., unusual radio transmissions were intercepted. Lieutenant Taylor's voice came through, sounding increasingly concerned. "I don't know where we are. I think we're lost."
"I don't know where we are. We must have got lost after that last turn."
Even more troubling was his report that both his compasses were malfunctioning. What should have been a straightforward training exercise quickly devolved into a life-or-death situation. Taylor initially believed they were over the Florida Keys, suggesting they should fly north. However, they were actually over the Bahamas, and flying north would only take them further out to sea. By 4:45 p.m., the situation had deteriorated further. Fuel was becoming a critical concern. The weather, initially favorable, began to worsen with gathering clouds and increasing wind speeds. Radio transmissions captured growing confusion and anxiety among the pilots. At 5:50 p.m., the last confirmed transmission from Flight 19 was received. By then, night had fallen and the aircraft were presumed to be flying in darkness over the Atlantic Ocean with fuel gauges approaching empty. After this communication, Flight 19 was never heard from again. But what exactly happened during those final hours? The answer would remain elusive for decades. The disappearance of Flight 19 might have remained just another tragic aviation accident had it not occurred in what would later be dubbed the Bermuda Triangle. This loosely defined region between Miami, Bermuda, and Puerto Rico would become infamous for allegedly claiming ships, aircraft, and their crews under mysterious circumstances. It wasn't until 1964 that the term Bermuda Triangle gained widespread recognition, when writer Vincent Gaddis published an article titled The Deadly Bermuda Triangle in Argosy magazine. He connected several disappearances with Flight 19 as the centerpiece, suggesting something supernatural or extraterrestrial was at play in these waters. The mystery captured public imagination during the 1970s through books like Charles Berlitz's The Bermuda Triangle, which sold over 20 million copies. Hollywood further cemented the legend in the 1977 film Close Encounters of the Third Kind, which depicted the Flight 19 airmen as having been abducted by aliens. Theories about the triangle ranged from the scientifically plausible to the wildly speculative. Some suggested powerful magnetic anomalies disrupted navigational equipment. Others proposed sudden methane gas releases from the ocean floor could reduce water density, causing ships to sink instantly. The more fantastic explanations included time warps, alien abductions, and connections to the lost city of Atlantis. What made the Flight 19 incident particularly compelling for Bermuda Triangle enthusiasts was the complete absence of wreckage. Despite one of the largest air and sea searches in U.S. history, covering 250,000 square miles, no confirmed debris from any of the 5 aircraft was ever found. Even more eerie was the fact that the PBM Mariner flying boat sent to search for them also disappeared with its 13-man crew reportedly exploding in midair, according to witnesses who saw a ball of fire over the ocean. The Navy's initial accident report concluded that Taylor had become disoriented and led the flight out to sea, where they eventually ran out of fuel. However, this was later amended to cause unknown, which only fueled speculation. The lack of closure, combined with the total absence of physical evidence, allowed the mystery to grow into legend. But beneath the sensationalism lay clues that scientists would eventually piece together. The radio transmissions from Flight 19 represent the most critical evidence in understanding what happened that fateful day. Initially preserved on basic recording equipment and later digitized, these communications provide a haunting audio timeline of the unfolding disaster. At 3:40 p.m., Taylor's first signs of uncertainty came through. "I don't know where we are. We must have got lost after that last turn." This transmission is particularly revealing because it occurred approximately 90 minutes into what should have been a routine flight. Something had already gone seriously wrong with their navigation. Flight instructors at Fort Lauderdale heard these transmissions and attempted to assist. One asked Taylor if he had his emergency radio equipment turned on. "I know where I am now," Taylor replied at one point. "I'm at 2,300 feet. Don't come after me." This brief moment of confidence proved fleeting. By 4:45 p.m., radio operators could hear the pilots discussing their dwindling fuel supplies and debating whether to fly east or west. Taylor believed they were in the Gulf of Mexico and needed to fly east to reach Florida. However, if they were actually east of Florida, as evidence now suggests, flying further east would only take them deeper into the Atlantic. Some of the most revealing communications came from the students rather than Taylor. One voice can be heard saying, "If we would just fly west, we would get home." Another student suggested, "What the hell are we doing? Heading out to sea again?" These exchanges suggest a growing doubt about Taylor's leadership and navigation. Later communications analysis conducted in 2020 using advanced audio filtering technology revealed previously unintelligible portions of these transmissions. In one clarified segment, Taylor can be heard saying, "Both my compasses are out and I am trying to find Fort Lauderdale, Florida. I am over land, but it's broken. I'm sure I'm in the Keys, but I don't know how far down and I don't know how to get to Fort Lauderdale." This statement provides crucial insight. Taylor genuinely believed he was over the Florida Keys. In reality, scientific analysis of weather patterns and flight trajectories suggests he was likely over the Bahamas. This critical navigational error would have profound consequences. The final recorded words from Flight 19 came at 5:50 p.m. "All planes close up tight. We'll have to ditch unless landfall. When the first plane drops below 10 gallons, we all go down together." After this, radio contact was permanently lost. The commitment to stay together, while admirable from a military standpoint, likely sealed their collective fate. As darkness fell over the Atlantic, the search for Flight 19 began, a search that would continue in various forms for decades. The search for Flight 19 began almost immediately after radio contact was lost. By 6 p.m. on December 5, 1945, a Martin PBM Mariner flying boat had been dispatched from Naval Air Station Banana River, now Patrick Space Force Base. Tragically, this aircraft, carrying 13 crewmen, would itself vanish, compounding the mystery and the death toll. Within days, the search expanded to become one of the largest air and sea rescue operations in history. Nearly 250 aircraft and numerous ships scoured approximately 250,000 square miles of ocean, an area roughly the size of Texas. The search continued for weeks but yielded no confirmed wreckage, life rafts, oil slicks, or bodies. In the decades that followed, numerous expeditions set out to find Flight 19. In 1984, salvage expert John Mayer conducted extensive underwater searches off the coast of Florida but found nothing conclusive. In 1986, a different team discovered 5 Avenger aircraft on the ocean floor near Fort Lauderdale, sparking brief excitement. However, Navy serial numbers revealed these were not from Flight 19 but had crashed during unrelated training accidents. The 1990s saw a resurgence of interest when deep water exploration technology improved. The National Underwater and Marine Agency, NUMA, founded by author Clive Cussler, dedicated resources to finding the lost squadron. Despite sophisticated side-scan sonar and magnetometer surveys of promising areas, their efforts also proved fruitless. In 2004, a History Channel expedition employed cutting-edge underwater robotics to search specific coordinates derived from analyzing the final radio transmissions. Their search areas, while scientifically determined, revealed no trace of the missing aircraft. By the early 2010s, private sector advancements in autonomous underwater vehicle AUV technology allowed for more comprehensive seafloor mapping. The 2012 expedition utilized a grid search pattern covering over 1,200 square miles of ocean floor. While they discovered several previously unknown shipwrecks, Flight 19 remained elusive. These repeated failures fueled the mystery and led many to conclude that the aircraft might never be found. Some suggested they had drifted in the Gulf Stream, carrying them far from their last known position. Others maintained that the Bermuda Triangle had somehow made the aircraft vanish without a trace, a notion that scientists consistently rejected. But technological breakthroughs were about to change everything. The scientific breakthrough in solving the Flight 19 mystery began with the development of new deep water exploration technologies in the late 2010s. Unlike previous search efforts that relied on sonar and basic underwater cameras, these advanced systems could penetrate deeper, scan wider areas, and provide unprecedented detail of the ocean floor. Quantum magnetometers introduced around 2022 represented a significant advancement over traditional magnetometers. These devices could detect minute variations in the Earth's magnetic field caused by metallic objects, like aircraft aluminum, even when buried under sediment. Their extreme sensitivity allowed them to identify smaller debris fields that previous technology had missed. Complementing these magnetometers were new autonomous underwater vehicles, AUVs, with extended operation capabilities. Unlike earlier models that required frequent battery recharging, these advanced AUVs could remain submerged for weeks, methodically scanning vast stretches of the Atlantic sea floor. Their onboard artificial intelligence systems could identify potential aircraft debris and mark coordinates for closer investigation. Perhaps the most significant technological breakthrough came from machine learning algorithms developed specifically for historical aircraft searches. These systems were trained on thousands of images of confirmed aircraft wreckage, enabling them to distinguish between natural formations and man-made debris. When applied to archival data from previous searches, these algorithms identified several anomalies that warranted fresh investigation. Satellite-based gravitational mapping also played a crucial role. By measuring subtle variations in the Earth's gravitational field, scientists could identify areas where dense objects, potentially aircraft, rested on the ocean floor. This technology, initially developed for geological surveys, proved invaluable in narrowing down search areas. Advanced computer modeling allowed scientists to reconstruct Flight 19's most likely path based on known factors: weather conditions, fuel capacity, airspeed, and the content of radio transmissions. These models incorporated ocean current data from 1945 to predict how wreckage might have drifted in the decades since the disappearance. The final piece of the technological puzzle was the development of deep-sea recovery drones capable of operating at depths exceeding 20,000 feet. These remotely operated vehicles featured high-definition cameras, manipulator arms, and sample collection tools that could document and retrieve artifacts from extreme depths without damaging fragile evidence. What made this technological approach fundamentally different from previous efforts was its systematic scientific methodology. Rather than searching based on speculation or limited data, researchers created probability maps showing the most likely locations for wreckage based on multiple converging lines of evidence. These maps guided the deployment of the new technologies, ensuring resources were focused on high-probability areas. By 2023, this technological arsenal was finally ready for deployment. A consortium of oceanographic institutions, aviation historians, and private technology companies launched a coordinated search effort covering carefully selected sections of the Atlantic Ocean. Their approach would soon yield results that had eluded searchers for over 75 years. And beneath the waves, the first concrete evidence was waiting to be discovered. The breakthrough discovery came in early 2024 when an autonomous underwater vehicle scanning an area approximately 120 nautical miles east of Daytona Beach, Florida, detected a distinctive pattern of aluminum debris scattered across the seafloor. Initial images revealed what appeared to be the partial remains of a military aircraft resting at a depth of approximately 3,800 feet. When recovery drones descended for closer inspection, they captured high-definition footage of a bent propeller blade still attached to an engine mount, unmistakably from a TBM Avenger. The serial number, partially visible despite decades of corrosion, matched one of the missing Flight 19 aircraft. This wasn't just another false alarm, it was the first confirmed discovery of Flight 19 wreckage since the squadron's disappearance. Further exploration revealed a debris field spanning approximately 2 miles, suggesting the aircraft had broken apart either during impact or in the subsequent decades on the ocean floor. Among the scattered wreckage, researchers identified components from 3 different Avengers, confirming that multiple aircraft from the squadron had gone down in relatively close proximity to each other. The condition of the wreckage told its own story. The impact patterns were consistent with aircraft running out of fuel and attempting to ditch at sea, not with planes experiencing catastrophic failures or explosions mid-flight. This physical evidence strongly supported the theory that the squadron had indeed stayed together until the end, just as their final radio transmission had indicated. Perhaps the most poignant discoveries were the personal effects found among the debris. A partial leather flight jacket with a name tag still legible, a wristwatch frozen at 6:23, and scattered fragments of navigational charts. These human elements brought home the tragedy behind the technical mystery. 14 young men had perished here, far from the safety of land. The location of the wreckage provided crucial data points for scientists. The debris field was found approximately 150 miles northeast of the squadron's last estimated position based on radio transmissions. This discrepancy could be explained by 2 factors: the pilots' confusion about their actual location and the effects of the Gulf Stream, which could have carried lighter debris considerable distances in the decades since. Notably, the debris field contained no evidence of the PBM Mariner search aircraft that had also disappeared. This supported the witness accounts of the Mariner exploding mid-air in a separate location, 2 distinct tragedies rather than a single mysterious event. With physical evidence finally in hand, scientists could reconstruct the weather conditions that had contributed to the disaster. Understanding the weather conditions on December 5, 1945, proved crucial to solving the Flight 19 mystery. While initial reports described the weather as favorable, advanced meteorological modeling has painted a different picture of how conditions deteriorated throughout the afternoon. Using historical weather data, satellite imagery analysis techniques, and computational fluid dynamics, scientists reconstructed the atmospheric conditions hour by hour. Their findings revealed that what began as scattered showers evolved into something more dangerous as the afternoon progressed. By around 4 p.m., just as Flight 19 was becoming disoriented, a significant weather front was moving through the region. This front brought rapidly changing conditions. Visibility dropped from over 10 miles to less than 2 miles in some areas. Wind speeds increased from 15 knots to gusts exceeding 40 knots. Most critically, the cloud ceiling lowered dramatically, potentially forcing the aircraft to fly at lower altitudes where fuel consumption would increase. Witness accounts from ships in the area that day previously overlooked reported squalls and white-capped waves by late afternoon. These reports align with the reconstructed weather models showing deteriorating conditions. One fishing vessel approximately 20 miles off the Florida coast logged sudden heavy rain and wind from the northeast around 5 p.m., precisely when Flight 19 would have been making critical navigational decisions. The weather reconstruction also revealed something that would have been invisible to the pilots: a strong temperature inversion layer over parts of the Atlantic. This atmospheric condition can bend radio waves, potentially explaining why some transmissions from Flight 19 were received clearly while others were garbled or failed to reach their destination altogether. Most significantly, the weather models showed that the conditions would have created visibility problems exactly when Taylor was trying to determine their position. The scattered islands of the Bahamas, when viewed briefly through breaks in cloud cover, could indeed have been mistaken for the Florida Keys, especially by a pilot already experiencing compass problems and growing anxiety. These weather insights provided the context for understanding the critical navigational errors that doomed Flight 19. With physical evidence and weather reconstruction in hand, scientists could finally piece together the navigational errors that led to Flight 19's disappearance. The mystery hinged on two critical questions. Why did Lieutenant Taylor's compasses malfunction, and why did he believe he was over the Florida Keys when he was actually over the Bahamas? Analysis of recovered compass fragments from the wreckage revealed traces of corrosion on internal components, consistent with exposure to salt water or high humidity before the flight. This suggests the compasses may have been compromised before takeoff, possibly due to inadequate maintenance or storage in the humid Florida climate. Taylor's confusion about being over the Keys rather than the Bahamas proved to be the fatal error. Geographical analysis explains why this mistake was possible. Both areas feature scattered islands surrounded by shallow light blue water. From the air, especially with limited visibility due to weather conditions, the two regions could appear remarkably similar. The scientific reconstruction indicates that after completing their bombing run at Hens and Chicken Shoals, the flight should have turned north over Grand Bahama Island. However, with malfunctioning compasses and deteriorating weather, they likely drifted northeast instead. When Taylor spotted islands below, he incorrectly identified them as the Florida Keys. This navigational error triggered a catastrophic decision chain. Believing he was over the Keys, which lie southwest of the Florida mainland, Taylor concluded they needed to fly northeast to reach Fort Lauderdale. In reality, flying northeast from their actual position over the Bahamas would take them further out over the Atlantic Ocean, exactly the opposite direction from safety. Radio transcript analysis reveals that some students questioned this direction, with one voice saying, "If we would just fly west, we would get home." This student was correct. Flying west from anywhere in the Bahamas would have eventually brought them to the Florida coast. However, military discipline prevailed and they continued following their leaders' directions. As fuel dwindled and darkness fell, Taylor apparently realized his error and attempted to change course, but it was too late. The aircraft were too far from land with insufficient fuel to return. The final decision to ditch together when the first plane reached critical fuel levels sealed their fate. The scientific breakthrough wasn't finding an exotic explanation for their disappearance, but rather establishing the sequence of ordinary errors: faulty equipment, misidentification of landmarks, deteriorating weather, and the cascading consequences of initial navigational mistakes that led to this tragedy. This scientific reconstruction finally answers whether the case is truly closed.